Hello, my name is Mark Kortschott. I'm an engineering professor at the University of Toronto and a member of our Centre for Global Engineering. I would like to introduce you to our design for a new toilet for the developing world. This project was undertaken with the support of the Bill and Melinda Gates Foundation under their Reinvent the Toilet Challenge, part of their water, sanitation, and hygiene program. The program asked for a toilet capable of disinfecting human waste within about 24 hours, that would be inexpensive to build and operate, and would require no hookup to running water, a sewer system, or supplied electricity. A team at the University of Toronto undertook this challenge together with partners at the University of Edinburgh, the University of Western Ontario, OCAD University, and technical experts in Bangladesh. Here is our solution. Instead of a traditional Western-style toilet where a user sits on the bowl, we are using a squat toilet design, which recognizes the current practices in many of the developing countries where this toilet would be used. The bowl is set in the floor and contains 3 holes, one for urine, one for feces, and one for water used to wash after defecating. It is important for us to separate the solids and liquids, as we have 2 different methods for processing them. When the user defecates, the feces will fall onto an inclined belt. If the stool is runny due to diarrhea, the liquid will run off the belt and be handled by our filtering system for water and urine, which I'll describe momentarily. The solid mass will remain on the belt. Instead of flushing, the user will instead turn a crank that will move the feces through a narrow roll nip to flatten it so that it can dry quickly. As each subsequent user defecates and turns the crank, the feces moves slowly along a drying belt and becomes harder. After several hours, the solid feces will be dropped into a smoldering chamber. Smoldering is an energy-efficient and self-sustaining combustion process where the combustion travels through a porous material. This is what happens in a charcoal barbecue. Once the fuel is ignited, it will continue to generate heat until it is extinguished or there is nothing left to burn. Of course, the combustion will destroy the pathogens in the feces. The exhaust will pass through a series of filters that will eliminate the odor. In the end, all that would be left is ash, which would have to be removed periodically from the smoldering chamber. Liquids, including diarrhea, urine, and wash water, are directed to a sand filter. This filter is designed to capture solid particles and parasitic eggs that may be present, while allowing clarified liquids to flow to the bottom. The filtered liquid, or effluent, is sent through a chamber that uses UV light to kill microscopic pathogens. The disinfected fluid can then be discharged. The filter is special because sand is fed upwards from the bottom using an auger. This ensures the most contaminated sand is pushed to the top. There it is skimmed off using a paddle and placed onto a second belt that transports it to the smoldering chamber, where it is incinerated. The UV light and the power needed to operate a small fan for drying can be supplied by a modest solar panel and battery. What is novel about this design is its simplicity. None of the processes taken individually is particularly complex. However, by bringing them together to solve this challenge, we can ensure better sanitation is provided to remote and impoverished areas of the world. Talking about feces and urine is not a pleasant topic, but the spread of disease through contaminated feces is a pressing challenge. More than 1 million children die each year from diarrheal diseases, and most of these deaths could be prevented with the introduction of proper sanitation, along with improved hygiene and better drinking water. The University of Toronto and our partners are glad to contribute our engineering and research skills to find a solution to this problem. Thank you for watching.